the music is ending, then thank you here. Thank you everyone for joining this session. We'll talk about architecture, debugging, coin dependency injection, and a new platform called Kotzilla. This is a workshop, a live workshop that we will make. This is something you can do by yourself. If you have a laptop, there is some table just behind, just in front here. If you need, there is lots of space, perhaps some electricity. Then if you need to pose yourself in a good way, you have tables, you have chairs, you have everything else you can follow. We will make the workshop live. That means that if you don't have the laptop, you will see how it goes and what we are solving. And you will also have all the resources to play it at home when you have time. I'm Arnaud Giuliani, creator of Koin project, CEO of Kotzilla, and here also Miguel presenting with me.
Hello everyone. Want to be doing also most of the steps of the workshop and the videos. So glad to be here with you on the following 1 hour and a half, I think, no? 1 hour 15.
75 minutes.
Yeah.
Well, should be cool. Kotzilla is part of the Kotlin Foundation. That means that we are working with Google and JetBrains to shape around the Kotlin language and try to make it better for everyone. And that's cool here to be part of that. And here's a summary. Then we have a few introduction about Koin, especially perhaps to know you a bit better. Just raise your hand if you don't know Koin, the framework. Okay, just two of you. Yeah, you won't have to know and to understand Koin. We will just play around, and you don't have to have some knowledge to be able to make the workshop. Then you will be able to play the workshop by yourself. No worry. This is the workshop repo. Then this is on workshop.kotzilla.io. Either you can screenshot the QR code. I will present it later after the introduction, but you can already clone the repository and try to check out, open it with Android Studio for those who are already that have their laptop ready. Then you can start, because the Wi-Fi bandwidth is not super great. Then I advise that you start looking at that and clone the repo. The repository is a version of a Google application, the Now in Android application that is kind of the demonstrator of all the blueprints from Google, but migrated with Koin. And then we plot some issues inside to let us really chase them and then use the platform to work with that. A bit of introduction. Also, you will see we have a plugin. We have a plugin for Android Studio. You just need for the workshop and for the platform workshop and the plugin, you need a free account. Then you just sign up at kotzilla.io and then you register freely. Just have an email and then you're good for activating the free plugin. Let's talk a bit about Koin framework. And Koin is a framework that is in the Kotlin ecosystem since 2017 and really have lots of big applications and big players. Then, this is really lots of applications are really pushing Koin at some level, and then you can ask players like Waze or McDonald's that are really scaling their application with Koin, and lots of banking, video streaming, lots of many different kind of industry that are using Koin. Then that's really interesting. Koin is really, since the beginning and stay in its mission, easy to learn and productive in the way like it doesn't ask you to add other plugins, other stuff. Then it's pure Kotlin for you. There is no compile time overhead. That means that was the mission. And it's idiomatic Kotlin. That means it's pure Kotlin and Kotlin function. What you write is clearly pure Kotlin. Then you have several ways. Then Koin really is about the Kotlin DSL and also annotations for those who want compile safety part of their game. But DSL is fine, and lots of people love the DSL, and this is the core DNA of Koin. Everything is based on pragmatic API. The thing is, we make the plumbery, and you make the fun. You make the fun of your application and have to leverage the best of that. And you have several solutions to make the safety. You have safety API where we offer a test API. You just run JUnit, a bunch of stuff around your modules, and then you can have a bit of you can have safety, or you can really trigger compiled safety at key SP level, and then you have the compiled safety ready for Koin. And Koin is KMP compatible since 2018, and really it's one of the earliest framework to bring all the capacity of the Kotlin language to help you share and make dependency injection across platforms. Globally, we will have this big picture of architecture. This is something we will look at in our workshop application, right? But this is globally the basic, the standard application architecture with layers from the UI layer, where you have all your UI component, composable, activity, fragments, your presentation layer with view model, and then you have, under that, you have your domain layer with business logic, and then data layer and system layer, right? This is what usually, globally, we have classically in our mind when we build our system without talking about clean architecture and stuff, but in between you always have your UI, your data source, and you want to reuse some business logic. This is where you have always this in-between layers. Today, when you declare and you want to make DI, and this is the DSL way to go with Koin, is you can use the constructor DSL. This is one of the DSL part where you don't have to specify get and other things. But mostly, view model of will declare an instance of view model. Factory of will declare an instance of something that is created once. And then after that it will be every singleton instance. And you see how we can implement easily this kind of architecture from the view model, the use case, the repository, and the data source directly with a few lines of configuration with Koin. And clearly the beautiful picture is that you can really make your configuration file completely separated from your application, and you can really concentrate and focus on your configuration in one way and focus on your application on the other way. The good thing, and then Koin is part of the Android ecosystem from the beginning and is using the same official API as the HILT framework. That means that every HILT, every view model integration, for example, is using the same API has HILT and other, is using the same official API, right? Then Koin view model, the injection of a view model inside Compose, is using the official API proposed by JetBrains and Google, because Google is proposing all the Jetpack Compose API, and then JetBrains is making all the Compose multi-platform part, right, for the iOS. And the magic around that is like Koin view model is fully multi-platform. You can use injection of Compose of a view model inside a composable function, a UI, that will just run on iOS and Android, and you can really benefit from about your view model inside that. Then that's really cool, because this code is running on Compose multi-platform. It runs on iOS, right? And this is one of the examples of JetBrains. When you look at the Hello World example of JetBrains, you have Koin inside, and this is one of them when you can run just a least detailed application. This is a small one, where you have both Android rendering and iOS rendering. That's super cool, because this is exactly the same code, and you make dependency injection inside of that. There is people that really talk about pragmatic API, doubt about the capacity to make independence injection, or doubt about service creator things, but just to remind also that by view models, this is the Android API, okay? That means that this is the way the Android team designed the view model injection inside an Android application. Then really this delegate way to inject by property an instance of view model is really something that is not exotic. And this has been inspired by the Koin design, because by view model was designed in 2018, and the official new by view models API of the Google team has been designed in 2019. Then really, they seen that the ecosystem was super interesting to have really automatic Kotlin expression, because finally it lets you really write things in a super great way. Then. by view model, by inject are really meant to be used in your UI place to where you don't have constructor injection capacity, right? And finally, about the adventure from Koin to Kotzilla, one of the main things we were looking at performance and helping people build up and scale up with architecture and their application. And globally, this is the time of resolution inside Koin, 0.005 milliseconds to 0.01 milliseconds. That's super, super low. This is effectively Koin is kind of super fast meta index that really solve things super fast. You can really solve in a few milliseconds hundreds and hundreds of instances. That's not a problem. The problem is about what do we do behind that? What kind of application are we building? And this is where Kotzilla, the company that is really backing up all of this, finally, this is where we are making connected services on top of Koin and trying to make you measure the cost of your architecture, understand how your application is running. And we have the understanding of your dependency injection. Then we understand your core components, their life cycle. Then we can help you understand what's going on. And then also, our intention is really to deploy any capacity of letting you trace your components as much as you can to really mitigate any kind of incident later. And then we even project ourselves to really build up connected services, even remote navigation, remote activity navigation, because Koin is entirely dynamic. We can do a lot on top of that, right? And today we will already show how the platform is running, right? Then Kotzilla is the platform. It's an SDK that you wire on top of Koin that is making crash detection on Android. We are soon deploying for also iOS platform. It will spot critical issues that mean that you run session in development or production, and then we will spot where your component have a problem in terms of performances. This means that we can really see low signals in terms of main thread blocking or problem of allocation of memory and this kind of stuff. Then you will have access to user session replay, and all of this is purely Kotlin. That means that it's purely unified and usable in KMP, SCMP. What you will see is usable for a Compose Multiplatform or Kotlin Multiplatform application. Behind that, you will see that we are also allowing you to run all the analyze that we do for you. You can run it through AI as instant and then help you fix as fast as possible the kind of issues we will show you then. This is how it looks like. We will go in details with Miguel, of course. And we have dashboards we can do in detail in profiling graph, in a dependency injection graph, and so on. Then we will see in details how it goes and then what it looks like and what it detects inside our application, right? Finally, it's just one line of setup on top of Koin. On top, you need a bit of Gradle dependency setup, but it's just one line to set up that with your start Koin section, and then we activate all the analytics. With the platform, we have a new plugin, something you can run in your Android Studio, a plugin where you can really visualize your configuration. You can navigate into your configuration, and instead of having to find an interface, who is calling this, etc., then you can find the usage. You can really run through your declaration and usage. And also, we are doing live safety. That means that while you are typing, we detected your configuration, then we can really check if your configuration is good lively. We don't need to compile. It's not compile safety. It's even before. We can do lively a check on what you are writing. And then from all the issues detecting in the platform, we will show that directly in your code, and then you can ask the AI to look at the analyze from Kotzilla, and ask the AI will use your code, and then we will really target the context of the issue to say to the AI, you can look at this class and this class because this is this kind of problem. And then you will see that any kind of AI will be super efficient in terms of solving this kind of problem. A bit of screenshots, and Miguel, of course, will show you. But for example, here you have a navigation tree in your configuration. And then you will see that if you miss something, you will see it notified in your ID, right? Also, you can navigate to your configuration or to your declaration. Also, if you miss something, then you have it in the configuration tree, but in the code also we can highlight what is missing. And if there is critical issues detected on some class of lines, then we can indicate that, and then you can ask for help on this part. As I was saying, the plugin will help you make the right prompts. It is the end of my quick intro about Koin, about the ecosystem of Koin, Kotzilla, the platform, the plugin. If it's not already done, for those who would like to run the workshop, you will see it's not something where you have to code. It's just playing with the platform, spotting issues, spotting the thing we will see, like startup time, main thread blocking, this kind of stuff. Yeah. Is there someone that would like, they still need time? Just raise your hand if you still need time to check out, else we can move forward here. Then the project setup, the project that you will download is all ready to go. We just need to update the key. The key is Kotzilla.json. It's a bit like the Firebase JSON property files you have. And this Kotzilla.json, once you're connected to the platform, you download the key, you declare, you onboard your application, you download the key, and just replace this key with the Kotzilla.json file, and then just run the application, and you're fine. You don't have to do anything else. Now in Android, this is the application that we will use, and we try and we scrap to insert some issues inside. And this is the one that you can find on the official Google repo, and where they are demonstrating lots of patterns on compose, on navigation, on dependency injection, modularization. This is where we took that and migrated to Koin, and it's a newsreader. It's a newsreader about Koin, about Android news, and then we will use that to make the demo. It's time to make the workshop, and I believe, Miguel, you can start
Perfect.
things.
Thank you, Arnaud. So hope you are ready. We're going to switch from the French accent to the Spanish accent. So just let's change the piece here. Okay, so I don't know how many of you are going to run the workshop with us live. If you can raise your hands. It's just to make sure that then I spend more or less time on each step or not. Any of you is doing it live or no? One? Okay, one or two. Okay. So then I'm going to... Wi-Fi is not working? It's saturated already? Okay. Okay, so let me just try to guide everyone in the room as well. So, you know, the repo that Arnaud was mentioning is this one. This is available publicly. So you will see that, you know, the first thing to do is, of course, to clone this repo in Android Studio. I already did it to avoid all that time. And then, as Arnaud was mentioning, so to create an account in the Kotzilla platform that gives you access to both the Koin plugin and also the rest of the platform. No? So nothing magical here, just create an account with your email. And then we need to go to the registration of the application. So we need to set up the SDK to start also capturing the different data from the different user sessions and doing the analysis. So for that, you need to register the application. You will see that if you click on the register application, here in my example, if the network is working, I'm already login. So we support here the different kind of apps and projects that Arnaud was mentioning before. So you can register an Android app that is not using Compose, another one that is using Compose, KMP, CMP. And for those of you, we discussed with some of you that are developing SDK libraries, you can also set up the SDK for monitoring just an SDK library, independently of the application that are using it. So just need to select that, add an application name, and then the package ID, so we can recognize then also which is the app that is sending the data. And we're ready to go. So I'm going to be connecting, you know, I already did that, so just wanted to show you that in the application. So I created this I registered this application. So let me just bring you to the same. So I selected this application to be a Compose application. The Now in Android application that we are using here is also using Compose. So we're going to see some of the Compose navigation events that are captured. This is the name that I was giving, Now in Android. And then this is the application package. You will see that in the next sections is that pretty similar if you are used to configure other SDKs. You just need to configure a little bit the plugin that we're going to be using and the SDK setup. We did, Arnaud was mentioning that for the sake of the time today, we did all this configuration for you. You just need to do this first step, which is download the Kotzilla.json file that has been generated specifically for this app. So then we make sure that the data that is sent is sent in a secure way, and we are getting the data from that application. That, for example, if different persons here creates the same application with the same name, that's going to appear as different applications, and we're going to make sure that we are collecting only the data that is supposed to be. So that's the only step for those of you that are doing the workshop. You need to download this Kotzilla.json file, and as we mentioned here, you need to put it in your app module. If we've selected before, for example, a KMP or a CMP app, then you need to put it in a different directory, for example, in the share module, in which, of your KMP app. So all that is automatically updated in the onboarding, depending on the app that you are mentioning. Just even if all that is already configured, I wanted to show you for the rest of the audience that, the rest of the configuration is just here we are using version catalog. So it's just to specify which is the version of the SDK that we're going to be using. In that case, is the 1.3.0, released last week. We like to take risk. And then here you have, then the library, and we're going to be using here the SDK Compose. So we have two versions of the SDK, one that is using Compose, that is not using Compose. The only difference is that one is collecting those events, the other one is not collecting the Compose events. And then, as in any other SDK config, so then we need to activate, the plugin here in the build.gradle file, and we are ready to go. So the last step is just, as Arnaud was mentioning, to define, to start collecting the analytics in the place in which you are starting Koin. Again, this is an Android application, so we do it here at that application level. If this was a CMP or a KMP app, you need to do it where you initialize your Koin, usually in the share module of your app. So that's done. So after that, you should be able to to have this new app register, and we should be ready to start capturing user sessions and analyzing the data and potentially identifying some issues. So that's something that you can do. So here I have still one running. So you can just run your application. So here I'm using the emulator, to avoid, it's way easier for testing purposes. So we just run the app. I don't know, for the people that are doing the workshop, is that working? Have you successfully registered the application on?
Yeah.
Yes. Can you zoom? Yeah. Let me just.
Font size.
This is in settings, right?
Mm.
And here.
Font size to.
No, it's not
18.
here. What is the font size?
No, not this one. Tab font. No.
It's here, no?
Wait.
And this one should be something like 18, maybe?
Yeah, it will be better.
Is that better? Perfect. OK, so just after launching the app, so we're going to interact a little bit. So you see the app that Arnaud was mentioning, the Now in Android. So I'm going to just do some clicking. So that simulates a user session that has been created, so a whole user interaction. So I'm going to do here, go back. I'm going to unsave here some of the articles. And I'm going to click here on the interest button. You will see that this is the first issue that we're going to generate. Clicking on the interest tab is actually going to generate a crash that we have introduced in purpose. So we're going to click here. So the app is stopping. I'm going to just click again on the app to make sure that we send this crash on the next associated to this session. And then what we could do is, that's kind of the first exercise that we had here. Let me just go back here. Yeah. No. Okay, we launch the app. And as I mentioned, yeah, we're getting some time for load. The first exercise of the workshop is try to identify that this crash was happening, and then try to solve it. No, so that's what I did. Just run the app, click on the button, and then trying to find where the crash is coming from. So there are two different ways to see the different issues that were captured for that particular user session. You can go into the console. That's what Arnaud was mentioning before. So here you have a dedicated dashboard for this application. You will see here that we have 13 sessions already created. So I was testing that a little bit before the workshop today to make sure that we had also some data. But actually, every session is generating the same kind of errors because we introduce the same issues. No? So you see here that, okay, we have a list of, we have also the version. So we, of course, if we had different versions of our application, we could also compare the performance. We see here the number of sessions. We should also find the last one that we've created. We have the number of events that were captured. An event is, basically extracted from the different logs that we are analyzing at Koin. In this case, it was only one device. Just to mention, in this example, I'm using the emulator, but if you have different devices, or even if it was a CMP app with some iOS devices and Android, you will be able to see that and filter by device. And then the number of open issues. So actually already 26 issues generated. And so at some point, if we look here, we should find a crash. So if we click here, we have the crash that we saw in the first step of the workshop. So we have here the stack trace. So actually, if I copy this and if I go, we should find exactly what went wrong. Okay, so nothing really fancy, make it crash. So we introduce it a crashing purpose. So just to mention that the stack trace was corresponding to that. But what is more interesting is that you can also filter and go have a deeper visibility into each one of the user sessions that you want to explore. In this one, we see here that we created a user session 4 minutes ago, so it worked. You could decide to monitor only some user sessions, depending, as I mentioned, on devices, operating systems, and other factors. If I click on this last user session that I created, we go to this view, which is we call it the timeline view. This is, you see on the top, we call it the key moments. So you have all the key interactions that were recorded during that particular user session. That probably took a little bit less than a minute. So it's just to give you an idea about what happened. So you see that at the end, this fire is the crash. So the session ended up with that crash. So you have this information. But what is cool is that you also have before other issues happening. So we're gonna see that in a minute. So you see the other performance issues happening. And here in green and in violet, you have events that are not related to problems, but are here to give you information about all the compose navigation events that were recorded or any screen activity. No? So all that, you will see that is going to be available here in this detailed sequence of events in which we're going to see exactly every second what was happening and what were the issues. No? That should end up with the crash that we saw here. I'll come back to the other views. You'll see that there is some threading information. I'll come back to that in the next section of the workshop. No? Just wanted to show you that a crash was detected. We had the information on the stack trace to try to fix it, and then we can also get additional details if we analyze a user session. Something that is also cool is that for every issue, including a crash, so I should have also this crash appearing here in Android. So if you don't want to go to the web environment and you want to stay in Android Studio, the Koin plugin is also able to list all the issues that were detected. No? So the same kind of graphical dashboard that we saw before, you can find the similar information here. So here we have the crash that happened. And of course, sometimes it's just easier to try to fix directly the problem from Android Studio. One cool thing that we introduced is that we realized that we generate enough, or we have enough context to help you fix this crash this one was easy because we immediately saw that the crash was introduced. But we are able to generate, for more complex problems, a really contextualized prompt with all the info. For a crash, it's mainly the stack trace, but also some other contextual information that you can run and you can execute in one of your favorite coding AI assistant. I don't know if you are using any of those, Copilot, Juni, Gemini. You can raise a hand, the ones that are using on a day-to-day basis any coding assistant. Okay, we have a kind of a third. When we were interviewing a lot of Android developers over the last 2 months, we got like 90% of the people were using it. Some people were not authorized to use it, but they were using it anyway. and then a lot of people are actually saying that that's being debugged in the organization. Also, if you are using it and you wanna get some help, so know that we are able to generate a prompt. You will see that it's even more impactful for a performance issue. If you have different, any of those tools or assistants already available, you can either copy, for example, or send it directly. Here I'm going to use Copilot. And if we don't have any demo effect, if I go here and I say I'm going to use Copilot with Gemini Pro model, I'm going to just give visibility to my project, and I'm going to execute my prompt. So everything works fine. I should get that fix automatically done by Copilot using that model. No? Hopefully that is going to be working. So you will see that you can do the same with the performance issue. So we're going to see that in a minute. No? Come on. Okay. Continue. So we should get it here. The difference between, I don't know if you are knowledgeable about that, but the difference between using the agent versus the ask mode is that if you use the agent, then you allow automatically to provide a fix for you. If you're using the ask mode in the majority of those solutions, then you're going to have an interaction, but the LLM is not going to do the fix for you. So the good thing about that is that, of course, if you have the right context, you are working Android Studio, you can, usually the agent give really accurate results, and then it's up to you to accept or not the changes, no? Let's see if that was working. Examine the context. So I think it's something with the connection, no?
Well, the Wi-Fi doesn't help.
Yeah, the Wi-Fi is not working here. Okay, we'll try it again with a performance issue, but you get the idea, no? Okay, so that was kind of the first quick exercise that was identifying a crash, analyzing it, and then doing the fix. We're going to do something. I mean, you probably say, like, yeah, but I already have something similar with Crashlytics. I can already have the crashes, and I already fix it, and also they have some integration with Gemini. Okay, that's true. But you will see that it's getting more interesting. So in addition to crashes, we're also able to identify some ANRs or potential ANRs. And you will see that now having the coin visibility makes even more sense, no? So for the ones, again, doing the workshop today, or if you are doing at home, so something that we're going to be doing here is that we're going to see that the session that we have generated is also created this new issue, which is actually we will have a view model that is blocking the main thread, so potentially creating a freeze and potentially creating an ANR. And you will see that this one is happening in the main activity view model. So let's look for that. We don't need to create another session because we already have all the info, all the issues created. So we did that, to facilitate that. So here, if I'm looking for the main activity view model, here we have that issue that happens. One cool thing about using the Koin plugin is that if you click once, you are directly opening the file that is concerned. So usually that helps already on the investigation and the fix. If you click twice, it opens the console. So then you can go directly to get more information and try to examine, do an examination analysis of the user sessions, and even get more information. For example, what's happening here? So we have a view model that is taking more than 100 milliseconds to execute. We tell you what potentially can happen. We still have access here to all the user sessions that were impacted, including the one I created 10 minutes ago. For each one of those user sessions, we see how long it took the resolution. That's way more than 100 milliseconds. It's actually taking more than 1 second, 1.5 seconds. And again, if we click to analyze that user session, in that case, we got redirected exactly to the point in time in the user session in which this thing was happening. No? If you are, of course, the majority of you familiar with Koin, you see that we can also provide you information about not only that resolution, but also about all the resolution graph associated to that component. So in this case, it was a really simple graph, only those dependencies, but it can get a little bit more complex. We'll see that also in the next example. Just by using that, you already have an idea or where the performance issue is coming from, because you see that all the dependencies are executed really fast, but we're still spending 1.5 seconds somewhere. So that's probably something wrong in the constructor, in the initialization of the view model itself. So these already give you an idea of where is this time spent, no? And usually that could be, for example, you are calling an external services, something, no? But yeah, so that's first thing. So as we did in the previous example, we can also generate here a prompt if you want to get the fix. This prompt is a little bit, if we look at that, also more interesting because we have also the context here. We have the information that we're seeing, but also we generate the whole info about the graphical, the graph, the dependency graph associated. So we can do the same, or actually we can use, let me use another one. We can use maybe Cloud CLI and send it directly and try to see if, I'm gonna close that so it's a little bit more complex for him. And the Cloud CLI should be able to detect what happened exactly in that particular view model and fix it. We'll see. It's a little bit long here, but you will see kind of the same approach. And I was telling that this is becoming more interesting, and then we see also how having the visibility and the context of Koin is important, because in those kind of performance issues, you know, having an idea about what is the component, especially knowing that it's a view model and having visibility on the resolution graph makes sense, no? Okay, so here we see that there was a problem because we introduced a blocking thread issue 1.5 seconds, so that was immediately spotted by Cloud CLI and fixed it, no? Again, this is really, of course, that was a heavy delay, but we have been testing that with really complex applications, and that was, you know, really useful and accurate, especially if you are executed in the context of Android Studio. Something that I didn't mention, but probably you saw, is that the same prompts can be generated also on the console. So if you don't want to use, or you prefer to use only the web environment, you can also generate a prompt from there and then run it elsewhere. Again, it's working, it's a valid option, but you're gonna get less accurate results than if you are doing that inside the Android Studio. Okay, yeah, so that was second issue that was detected and fixed. Let's move to the next one. Give you an idea as well about we are not only able to detect performance issues that are directly impacting your main thread, we can also detect performance issues that are having an impact of blocking one of your background threads. And you will see that we also give visibility into the background thread execution. You know, it's not because something is executed in the background thread that it's not also having an impact on the whole application performance, and even is visible for the user. So the two, of course, need to be monitored. So we're looking here for an issue that is impacting this worker, sync worker. If you know the now in a .NET application, that's probably explainable for you. And then it's a dedicated background thread issue. So same thing. If we move here again to the list of issues, I have a lot of issues here. We should get also the listener worker. It's not this one. It's not a worker. So the same component is impacted with is this one. So if we double click here, same thing, we can continue the analysis. You will see that the threshold is the same than before. Getting again some latency here on the, yeah, getting slow. Here we go. And this is something that I wanted to show is that, again, we are redirected exactly to the point in time what that happened. And we can also see here that, you know, there is a main blockage here on this background thread, no? If I decide to extend a little bit, you know, analyze the whole session, sorry, here, you will see that you can also get an overview immediately about the different threads of your application and where are you spending time. So here is another way to, in a quick look, to have a view of, okay, for that particular user session, are we spending more time on main thread, background thread? This is particularly useful, and this is a use case that we see a lot of time, is that sometimes you initialize a lot of things on the main thread, and this is blocking the main thread, and that's causing the performance issue. So sometimes you can decide to, thanks to that, to say, okay, yeah, maybe this is something that I can initialize on the background thread at the beginning because I don't need it yet, and then it's a good way to fix some of the issues. No, so this is where we add this kind of visibility between the main thread and other threads, because that gives you also an idea about what could be the fix, no? To delay some execution, to make some execution happening on the background thread. Something that we're also going to see in the next exercise is also we have a dedicated memory view. The idea here is not to replace a canary leak. The idea here is to help you identify if there are some memory issues related to the way you are using Koin and you are managing the different objects in memory. For example, you know, if you have spikes, that could mean that you are using factory in places in which, in components in which potentially should be a singleton, and you don't need to recreate it every time, no? So we're going to see that just after, no? Okay, give you an idea. I'm not going to run the same fix, whatever, on this issue, but you got the idea, right? Okay, yeah. So something that is not related to one specific component of your model itself, but more related to the slow startup, just to illustrate another issue that we can detect, is, you know, of course, if something is happening, you saw probably in the first run that I did on the user session that the application took some time to, you know, to load. It's because we introduced a 6.5 second delay there. So yeah, so one of the exercises, you can also do it also at home after the workshop, is that you see that we are also have a dedicated issue detection for a slow startup. Same thing. Clicking here is going to give us some visibility on what happened. Analyzing the same session is going to point at the beginning. And you have, this is where also sometimes it's interesting to get you know, additional visibility of some of the events that happened before, because then you can decide that, okay, maybe I need to add some additional you know, traces or information because I'm missing some visibility into what's happening. For example, common issue that we see on app startup with some real applications is that at some point you are calling an external services, payment services, so that is taking some time, and at the end it's like the app startup is 6 seconds, but you don't know exactly what's causing the error, so you want to add additional traces to get that information. So this is something that you can do. For example, here you see that in the sequence of events, it appears some traces. I'm initializing here. I'm doing the verification of the logger, and then I'm also calling the post-loading. So if you look to the code, you don't have that in the default version, but wanted to illustrate that you can also add your custom traces. This is not the default approach that we propose. Probably you got the idea at Kotzilla. With the SDK, we try to detect all those issues out of the box without you needed to do manual tracing. Like, for example, if you are using Firebase performance monitoring, which everything needs to be manually traced in advance. But if you want to add some traces, you can do it. So the SDK also has an API in which you can add those traces. So here it was just a simple example to say, okay, yeah, I'm tracing here. I'm tracing also in this on-post loading method. And as you can see, here is where we are adding the 6.5 seconds. So you have all those additional events in addition to the events that are automatically captured by Kotzilla. So you can do that kind of mixed approach, and it's actually really handy, especially in those situations, no? Which you want to track a specific method call. That's wanted to illustrate the API usage here. I was talking before about the memory graph, and also a common mistake, especially that can have an impact in big apps, which is, okay, yeah, I am using a factory when I should be using a singleton, or the other way around. So we see here that we introduce actually different of those issues here. For example, in a data coin module. So let me just show you here. So here everything is factory of, and actually should be a single of, because it's main repository where initializing that. You don't need to initialize it every time, so we did that in purpose, but that can happen. So wanted to illustrate here that you can also have a immediate view of that something went wrong if you analyze one of the user sessions. So for example, here in this memory graph, we see that the beginning of the user session, we created 26 objects. There were only 3 already in memory. By the way, if you were using coin scopes, you will also see the scopes here. That's another common mistake. People managing scopes manually. And so sometimes you forget to close a scope. And then, of course, that's increasing the memory impact. So this is we built something that helps you in the context of one particular user session to detect all that. And is there anything that is not managed as expected? I'm missing some to close any scopes? Those things that step by step can also at the end create a memory issue and even a performance issue, right? You also have the visibility here. So if you want to know exactly which are the components that were created, so we see here also that some of those components here are a factory, when actually they should be a singleton. And we see that because, a little bit later, when we needed them again, so we still have this spike in which we are creating all those objects again. So if we remove that and we launch a new user session, we'll see that this curve is going to be, we are going to be loading it at the beginning and then reusing it over time, no? Let me do another try on the prompt generation for one of those issues, because I think this one is pretty cool, which is, for example, let me see if this one is working with the network. For example, here we have one of these dependencies that is taking some time to execute because of that, also impacted by the misusage of factory versus singleton. If I generate a prompt here, let me try it again with Gemini. I'm going to close it, otherwise it's too easy. If everything works as expected, here we should get automatically a different set of fixes in different classes, saying that you are misusing factory of, you should be using single of, and doing the changes automatically for you. That's becoming a little bit more interested and a little bit harder to find than the 6.5 second delay on the app startup. So let's see if it's working. Otherwise, you can try it at home. I managed to make it work consistently, so it should work. We'll see. Looks like it's blocked here. Okay, maybe I'm going to continue and then I come back just in case. Okay, so that's, that was the exercise we wanted to illustrate here, singleton or single versus factory. Actually, that was the last one. Let's check. I think it's blocked. I think it's not. The connection is not good enough. Okay, so if you can try it at home. I don't know if somebody in the room managed to test this one. Also blocking? Okay. Okay. Okay, so maybe as we still have some time before opening for questions, something that I wanted to show you that is not directly related to the SDK, but is related to the capabilities of the plugin, as also Arnaud was mentioning, is that, even if you are not using the SDK, Actually, just the plugin out of the box is pretty handy. By the way, the plugin, you can get it here. Sorry, that's if you go to the marketplace, you can get that coin is the only plugin available. Free to use, you only need the account to create the account. And as soon as you open any of your projects using Koin DSL or Koin annotations, works for the two. You see already that we are able to detect all your modules. Here is quite simple. I mean, it's kind of mid-size, 20 modules, but it's working well, especially for people with hundreds of modules in their project. And Arnaud was talking that you can navigate. So that's what you see that there is a for you module. You also see the view model associated. You can also go to the different parameters. Arnaud was mentioning that we were able to navigate easily to the declaration. So you can see that it has been declared here. You can also see where it has been used. So we added all those capabilities to help you also develop on a day-to-day basis. All that is static analysis. You don't need to configure the SDK, so all that is working locally. And also, last thing, if I forget to declare a dependency here, you will see that we get automatically the real-time check. That's even before compilation. So you immediately get a sense of something that went wrong here. And there is even a dedicated view for that, no? Type is not declared. You see which one is impacted. So then same thing if we fix it, no? As soon as you fix it, real time is going to work. So I personally like to always use the plugin. Whatever I'm doing, just the development and also the static analysis or configuring the SDK and then analyzing and fixing the issues. And I'm using usually the console for getting additional information if needed. But yeah, but that's, you can do the two are available, no? Let's go back to, I think it will get blocked, no? Yeah, you get blocked here.
Oh, but you located around data module now?
Yeah. Confirm this apply first. Locate the. It's weird because it's located. You should find it already. Let me try with
GPT-5 or
Cloud Sonnet maybe. Let me try a new one. Okay, just let me do a last try on this one. Otherwise, you test it and you let us know if you have any issue. I think I should have it here. We'll see if it's better. Yeah, I was using the Gemini because they're having some issues with this model. That's something that I saw in the past. So let me try last one time with GPT-5. And then I think we are quite good on time, so we can open for any question. Okay, working on that. Maybe you have any question, any feedback?
The trace, is it built on OpenTelemetry or is it built?
It's built on, sorry?
OpenTelemetry or?
No, it's not built on OpenTelemetry. No.
You have the graph of the object created at the beginning. Do you know in which thread are they created, or is any graph to see all of them in the background? Is one main thread so you can?
You see it by component. So for each component, you can see you see the thread, and then you see the component, and then from the component you can go to the dependency graph. That's what.
One by one, you don't have a graph to see exactly how many you are
No.
doing, so you can have an imagination of the percentage of the objects created in main thread and the other in the background thread.
You can get it here, meaning that you have first a visual representation, and if you go here, you can see which ones were created. For example, even here.
If you click, you will don't have a.
So everything here was executed in the background thread. But you need to click on one of the threads to see what has been executed in that thread. So that's one way to do it. Like you see the threads, and then you click, and you see the components and the resolutions that happen in that thread. Or you go to a component, and then you need to go. You need to go the first way.
Show the sync worker, perhaps.
You have for workers and
You should see what thread then at the beginning.
I think we're not showing it here, no?
You have it because on the left you see what thread was used in your sync worker, for example. If you are using Rx Java, for example, you are still using Rx Java or dispatching with the coroutines. You will see that on the left thread graph stuff, but all your resolution will stick on this thread. Then the main graph will stick on that thread. It's more like if you just click here, not on the details. For example, this one, for example, it's the listenable worker.
Okay, yes, this one.
Yeah, it's the listenable worker.
If I click, but I'm not sure it's gonna change if I click here, for example.
No, it's because
it's because it's going on goal. Yeah. For example, if I'm changing here, I'm not sure that it's gonna update. No. So I'm selecting here another one. No, I think it's not. You need to go from here.
Right.
So, but something that we can do is like in the directly here in the details, we could just add which thread is executed because we have the information. So if it's that what you were looking, so we can do that improvement. Yeah, today you need to go to the graph first. Good catch. Any other? Yeah.
So it's possible to pull this data, like to pull we can just manage and create our own dashboard or something?
Yeah, not yet. We're going to be working on that. That's part of the roadmap to make some of it accessible, mainly the issues that has been detected. Do you have any particular use case in mind?
For example, how long it takes to create everyone, the start time, for example, to create monitors as well.
So yeah, we're going to make some of that accessible, especially, for example, we had some people asking because they wanted to automate that from the CI/CD, and then make sure that they can check if something went wrong and automatically do some reports, whatever, without needing to completely automate it. So yeah, we're going to be working on that, exposing that information.
Yeah, if you're using it in like Compose Multiplatform, is it possible to show you areas where it's doing a recomposition unnecessarily?
To show,
so again,
Doing recomposition, unnecessary recomposition, is it able to detect areas like that?
we don't address that in the way it will be super heavy for you to have on all your sessions to have that kind of recomposition detection. Then the trade-off here is really to say somewhere we know your navigation, but in terms of recomposition, this is not something we would like to push on every device, every stuff. And this is where after that, you could trace directly of the components around like a view model or something, and you could see who is called again and tried in an abnormal way, right? But the recomposition, again, we won't detect that. We are hooking on the navigation compose stuff, on activity, fragment state, etc., the normal stuff, but we decided to not track that for consumption purposes.
You see here in this trace the compose navigation event. This is the one that we are seeing here. Yeah, this is the details that we are logging today. Otherwise, it could be overwhelming. Yeah, that's been the first iteration. Any other question or suggestion? So I think we're good. Thank you very much.
Thank you.
We have a booth, so if you have any additional question about Koin or the platform, don't hesitate to come and see us in the booth. Thank you.
Thank you very much.